So it's really nice to go ahead and have a chance to be with you here today. I'd originally planned on a little bit smaller group, and because of that I thought we'd go around and introduce ourselves, but given the fact that we're a little bit larger group now, we probably won't. I do want to do two quick checks though. One thing would be, what's your level of experience with IPv6? If you have not done anything with IPv6, hands up. Bunch of folks. Have done some stuff with IPv6, hands up. And folks who are pretty expert in IPv6. Okay, a couple folks there as well. So that's great to go ahead and know. So I think we got about the right level today. We are going to be talking about IPv6 from a sender's point of view. And that's going to go ahead and be a little bit different than the way I normally conceptualize things, because for senders, it's just a different world. You're not ISPs, because the ISPs are off in the ISP closed colloquium right now. And you're not probably consumers, so we're just going to have a little bit different spin today on things. And the first question we really need to look at is, as senders, do you really need IPv6 right now? And the startling answer may be, well, you actually probably don't, if you're a sender. And the reason I say that is you already have IPv4 address space. And you also go ahead and have the ability to reach the sites that you're trying to communicate with over IPv4. If they have IPv6, they also have IPv4. So if you're really just a sender, you're probably okay. You don't need to necessarily do IPv6 right now, or probably within the next few years even. Everyone you need to reach will be still reachable via IPv4. You're not running out of address space. So as a sender, if you are a sender, you're in pretty good shape. Even if you don't need IPv6 though, a bunch of other folks do. So for example, ISPs go ahead and may be deploying new service to new customers. They may have customers who need additional additional address space for new devices. So in the old days, people used to have one computer. Now they've got a computer and mobile devices and PS3s and whatnot, and all these other things that all consume IP addresses. They're folks who are going to go ahead and be needing to be moving towards IPv6 pretty ricky-ticky soon. Some folks will talk about things like using network address translation as a way to go ahead and conserve addresses and avoid the need to go ahead and move to IPv6 very soon. But you'll see as we talk about things that that has some challenges of its own. The other group that really can't wait to go ahead and do IPv6 are some of the vendors out there. So if you happen to be with an appliance manufacturer, or you're doing software that supports the messaging industry, you really need to be getting on the stick pretty quick, because your customers need IPv6 for their operations right now. The good news is you're here, it's early in the morning, there's not a lot of other things going on. So even if you're a sender and you don't really need to move to IPv6 right now, I would suggest you go ahead and hang on a little bit and learn about it, and go ahead and maybe even try it when you get home. If you try it, it doesn't work well for you, you can always back it out. So it's really kind of a low pain, low problem option for you to go ahead and test. So the first part of this talk is really going to be just talking about what a sender would need to go ahead and do if they wanted to try IPv6. And then we'll go on to some other things like drivers and myths for IPv6. And then also we'll cover some technical material at the end. If at any point any of this doesn't seem relevant to you, feel free to just grab the slides and go ahead and get more coffee. It's not going to go ahead and offend me at all. But the point is we want to make this relevant for you. It's really sort of unfortunate, but email is the forgotten application of IPv6. And the reason I go ahead and say that is everyone is excited about v6 for web servers. I mean, that's really sort of the litmus test for whether a site is v6 enabled. Can I go to their website? Will it go ahead and show me the page if I'm using IPv6? Well, the point is that mail handles v6 in a little bit more transparent way, and no one really pays much attention to it. There are some sites that are deploying IPv6 for their mail servers, however. Here's an example for UCLA. Their mail exchanger records point to smtp.ucla.edu. If you look at that and ask to see the A records, you can see a series of IPv4 addresses. If you go ahead and look at that same address and ask to see a quad A record, the IPv6 equivalent, you'll see that they also have IPv6 addresses out there. So UCLA is an example of a site that actually does have mail enabled for IPv6. There are a large number of other sites that also have IPv6 enabled for mail. Things like Brocade, the storage fabric company, institutions like Maine.edu or Virginia Tech. There are providers like IIJ. There are exchange points like AMZIX. Certainly things like Aaron. So if you go down the line, you'll see that there are folks who are deploying IPv6 for email. However, in most cases, you'll notice these are technical organizations. You're not seeing a lot of consumer-grade operations that are up there, but that's coming. Some of you may go ahead and say, well, as a sender, what I'd like to go ahead and do is actually check to see whether or not the people I'm mailing to actually go ahead and have support for IPv6. You don't want to check it manually using DIG. You need something automated. This is a nice script that was produced by the folks at Genius.com. And I don't know if Frank's in the audience. No, maybe not. Anyhow, Genius.com is actually some folks you'll see here at MAAWG from time to time. And they've got a nice little script that you can use to go ahead and actually check to see whether or not the people that you might want to mail to have IPv6 connectivity. If they don't, well, that's okay. They probably will at some point. But remember what I told you, they're always going to have v4, at least for the time being. One of the things I want to mention to you is that even if you're interested in knowing who has v6 connectivity, you don't need to manually check. You don't need to manually test all your addresses unless you want to. It's going to be handled automatically. There's nothing you need to change in terms of the addresses you're currently mailing to. If they can do IPv6 from your IPv6 enabled systems and networks, they will. But you don't need to change everything. You don't need to insert IPv6 into the address or anything like that. That's not required. So the nice thing is, as a sender, if you simply go ahead and have v6 connectivity, if you have a v6 enabled operating system and you have a v6 enabled mail transport agent, if v6 is there on the other side, you'll just do it. The one thing I will also add is before you kind of go down this route and start enabling v6 and buying v6 stuff and so on, make sure you kind of think about the whole process. Because sometimes you'll have almost everything you need, but then you'll find you might have one piece of hardware in the path that might be a problem, whatever it might be. So go ahead and think about the entire process before you finally pull the trigger. Your first real requirement is to go ahead and get IPv6 connectivity. And this is really more a business function, a financial thing than anything else. So get your check writers to go ahead and call up your ISP and tell them you want v6. Now, you may have a strange experience when you talk to your sales agent. You may actually flummox them. They may say, v6, what's that? Because literally you may be one of the first few people to ask for it. In the event they tell you that they don't know about v6, ask them to ask someone else. Right? Because we see this strange phenomenon where people who definitely have v6 nonetheless tell you, well, I'm sorry, we don't have v6, or that will probably be several years in the future. Well, no, they often do have it, they just don't know it. At the same time you're getting that connectivity, also ask them for address space. And they're going to say, well, how much do you need, or how much do you want, or they may have some other questions. If that comes up, a /48 is fine, and we'll talk about what that means in the technical section of this talk. Sometimes you'll run into providers who genuinely do not have v6 yet, and if that's the case, well, your best bet's really to go ahead and add v6 connectivity from another provider. There's a list of transit providers at the bottom of the screen. If you grab the handouts, it'll be on there, or you can grab the slides. The point is you can go ahead and add v6 transit even if your current provider doesn't support it. One of the other questions that often comes up is, well, how much should I add? Should I go ahead and add as much v6 as I have v4? Well, you could, but that's really going to be overkill. What I normally suggest is that you purchase about 10% of the amount of v4 transit that you have. So if you have 100 meg of v4, maybe 10 meg of v6 would be a good target to shoot for. And initially, even that may be more than you need, but you're going to go ahead and grow, and you want room for some peaking and bursting and so forth. So, I think 10% is a nice target. Sometimes folks say, well, I heard I can get a free IPv6 tunnel, and that'll go ahead and allow me to do v6 over v4, and I'll go ahead and be good to go, and it doesn't cost anything, and it's all wonderful. Well, it's okay if you're an experimenter, if you're a developer, but it's not really what I would encourage you to use if you're doing production messaging traffic. If you're a sender, you want a rock-solid network. And tunneled traffic has some peculiar characteristics that may not be what you're looking for. So what I would suggest is if you can't get native v6, if you're a sender, maybe go ahead and wait. But you should be able to get it if you go ahead and check some of the sources I mentioned. The other thing you're going to need to go ahead and do is think about your equipment. So for example, you probably have one of several situations. You may just have been handed an Ethernet by a provider, and you plug it in and go. In that case, it's really going to go ahead and be incumbent on your provider to support IPv6. Some of you, however, may go ahead and have your own CPE, your own routers and switches and so forth. In that case, you're going to need to make sure that those routers and switches support v6. Most modern generation Cisco and Juniper gear won't have any problem doing that. But you may go ahead and run into some older gear, sort of geriatric stuff. That's either going to need to kind of get a little life support, heart stimulus going in there, or it may not go ahead and be able to do v6. Or if it does do v6, it may not do it at wire speed. So I guess the point simply I'm making to you is as you talk with your network engineering types, go ahead and make sure you recognize that some v6 equipment may not, or some equipment may not be v6 ready. Many of you will also have things like hardware firewalls. And if you have a hardware firewall deployed, again, it needs to go ahead and be v6 ready. Many are, some may not be. Sometimes you can go ahead and add v6 functionality by going ahead and upgrading the code or buying a v6 license. You may be licensed only for v4 sometimes. But in other cases, you may need to replace the firewall or bypass it to go ahead and handle v6 traffic. So those are the sorts of things that you want to make sure you're thinking about as you're doing your planning for this. I would also say that if you do have a firewall, you want to make sure that it's doing what you expect. So if you're thinking about IPv4 firewall rules, those aren't automatically going to go ahead and apply to v6. So you need to make sure that you have parallel rules in place to do what you expect, both in v4 and in v6. If you don't, you may by default block some v6 traffic that you want to permit, or you may permit some IPv6 traffic that you'd really rather not. The next thing on your sort of v6 planning list is really to think a little bit about your DNS servers. And there's really two different types of DNS servers that people use. One type is the authoritative name servers, the one that tell you, all right, I'm www.example.com, this is my IP address. The other type are the recursive resolvers, the ones that are used out there on the internet to go ahead and resolve all other domain names. You actually are using both yourself. The point is that both of those are going to need to support Quad A records. Those are the IPv6 records. Now, it's not necessary that your name servers be accessible via IPv6. That's nice, but again, you don't need to do that. They can be accessible via IPv4. They just need to know how to support IPv6. Most modern versions of Bind, the most common name server software out there, will do that. They go ahead and have very good IPv6 support. If you have a local recursive resolver that doesn't support IPv6, you don't want to upgrade it, one option would be to do something like using Google's intentionally open resolvers. Those are at the magic addresses 8.8.8 and 8.8.4.4. So, if you find yourself in a situation where your recursive resolvers don't support IPv6, you do have some free and sort of low-paying options. The good news as a sender is that you don't have to worry about a lot of other stuff. If you're ISPs, if you're not over in the ISP closed colloquium, if you're ISPs, they have to worry about some other things. They have to worry about all those little Linksys boxes that people have deployed in their home networks. Most of those Linksys boxes are not actually IPv6 compatible. So they may need to go ahead and be forklifted out and basically replaced with something that is. You don't have to worry about things like DHCP-v6. You don't have to worry about how to hand out IPv6 address space to all the different customers that they have to service. So there are a lot of advantages to not being an ISP if you're looking at playing with v6. The other thing I would note is that there may be other services that you currently use, like centralized syslogging or centralized device monitoring and management or centralized time service. If that's the case, you don't have to change those to v6. You can continue to run those over v4 and just do v6 where it's critical. So we talked about the fact that when you go ahead and arrange for your IPv6 transit, you're going to want to get address space. And you know, a lot of times if you're a sender, let's say you're a small sender and you've got a /24, 255 addresses. Well, if you get a /48, suddenly you're going to get just a few more addresses. I don't even know how to pronounce that size number except to say it's a whole bunch. I mean, 1 trillion, billion, million, whatever. The point is that you're going to get a large number of IPv6 addresses, even if you're just a small customer. If you go ahead and have trouble even conceptualizing a number that big, and I certainly know I do, it may help to think of that as having 65,000 subnets. And each of those subnets are going to have the ability to accommodate a huge number of hosts, but the point is you're going to have more than enough address space for any requirements you'll have in the conceivable future. I'm not going to go into how you should go ahead and arrange that space or IPv6 addressing plans. Talk with your network engineering types and have them make recommendations for how you go ahead and do that. Go ahead and assume that they will give you an IPv6 host address and that they'll also tell you your gateway address. Those are the two things they need to go ahead and give you. When it comes to your operating system, the good news is that most of them are IPv6 ready. You're not going to have to patch them. You're not going to have to go ahead and do much of anything except essentially to turn on v6. Sometimes folks will have an ancient version of an operating system that predates IPv6 deployment, and they may say, well, you know, should I patch it? And the real answer is if your operating system is so old that it doesn't support IPv6 out of the box, your first step should really be to upgrade that operating system before you do anything else. Otherwise, what's going to happen is you're going to have lots of things that are probably going to be unpatched security issues that are going to be a bigger issue for you than IPv6 support. So again, make sure that you're running the most recent version of the operating system that you're using. When it comes to actually enabling IPv6 on a server with a static address, the nice news is that it's very easy to go ahead and do that. These are pointers to recipes for standard versions of things like Red Hat or SUSE Linux or Ubuntu and FreeBSD Windows 2008. The point is that it's very simple to go ahead and do that. These recipes are quite brief. Just to give you an example for Red Hat, in Etsy sysconfig network, to enable networking, enable v6 networking, all you need to do is change one value to be yes instead of no. In the ifconfig script, go ahead and tell it also to go ahead and initialize IPv6 and provide those two addresses that I told you you should get from your network engineering types. At that point, you go ahead and restart your network services and you'll be live with v6. So literally, it's change two files and restart networking, and you're live on v6, assuming you have native connectivity. When it comes time to enabling IPv6 in your mail transfer agents, again, virtually all the modern MTAs are going to support v6. So things like Exchange, Exim, Postfix, Qmail, SendMail, they all support v6. The one place where we still have a few issues that may need to get resolved is if you use ProcMail as a delivery agent. ProcMail has not really jumped on the v6 bandwagon very quickly, and they're still listing it as a to-do item. So just as an example, if you want to go ahead and enable IPv6 and postfix, make sure you're running the most recent version. Take a look at the readmes as you always should. And then in the main.cf file, it's a matter of basically saying we want to use both v6 and v4 for the protocols. You have to tell it what address you're going to go ahead and be sending from in the main.cf file as well. And then check your files and restart, and you're good to go. So again, this is a very quick process. It's a very painless kind of process. Once you go ahead and enable it, check to make sure you can go to port 25 on it by using Telnet, and voila, suddenly you have a v6 enabled MTA. Now, I'm not going to tell you the world is perfect in v6 land for mail. As an example, things like DNS block lists that you may be too well familiar with are really still lacking. So we don't really have a good v6 block list position right now. We do go ahead and know that some things are improving, however. There's now a v6 whitelist available. So if you're a mail sender and you want to go ahead and make sure that folks can receive your traffic in v6, I'd encourage you to visit with folks like Spamhaus and get listed on their IPv6 whitelist. And the thing I will also say is we know that the folks who are doing the RBL DNSD, the software that is used for most of the block lists, I believe they're working on providing support for v6. It's just not there yet. SPF and DKIM, two perennially popular topics at MAAWG. Well, the good news is SPF supports v6 as well. DKIM is really IPv6 agnostic. So, what they go ahead and do doesn't even really depend on IPv4 or IPv6 addresses, so it also is good to go. So strangely enough, you now know enough to be dangerous. You really have a pretty clean agenda if you wanted to go ahead and enable v6 connectivity for your MTAs as a sender. And you can go ahead and actually try doing these things, and if it works, you're golden. If it has problems, you can back it out. You don't need it immediately as a sender.